Let's do a few examples. This first one right here, the 2x minus 3 and 5x minus 8. I do not know what that little line is. That is a 2x, I promise. This is already factored for you. We're going to start with a simple example so you can see what happens and why, and then we'll go to the factoring part and move on. But, so I have two factors, 2x minus 3 and 5x minus 8, and they're both equal to 0. Since these are multiplied together, what that means is that at least one of these factors has to equal 0 in order for me to multiply and get 0. The reason it is set equal to 0 is because, like I told you, that's what we're looking for. We're looking for the zeros, the place where y equals 0. So we always make y 0 and then solve. So since one or both of these has to equal 0, here is how I set this up. I take one of the factors, 2x minus 3, and either it has to equal 0, or the other factor, 5x minus 8, has to equal 0. So I take both my factors, set them equal to 0, and then I solve just like I would solve an equation to get down to what x should equal. So if I solve this, just like I solve an equation, you add 3 to both sides, you end up with 2x equals 3. And then you would divide by 2 on both sides, so you end up with x equals 3 over 2, or x equals 1.5. These are the same thing. It doesn't matter to me which one you write. It's not a repeating decimal. It's okay. And so what this tells me is that my quadratic, this parabola, if I were to graph it, crosses the x-axis at that point, 3 over 2, 0, or 1.5, 0. Then I do the same thing. This is my first root. This is one of the zeros or one of the solutions to my quadratic. The other one is going to be here. So I start by adding 8. So you end up with 5x equals 8. And then when you divide both sides by 5, you get x equals 8 over 5. Or x equals 1.6. They're again the same thing. Doesn't matter which one you use. But this tells me that my quadratic right here, if I graph it, crosses the x-axis at this point. The next one, x squared plus 13x plus 36 equals 0. Since it is equal to 0, I'm good. I can start. I just need to factor the left-hand side of the equal sign over here. So remember, AC method, you multiply a times c. Well, 1 times 36 is 36. I need two numbers that multiply to 36 that also add up to equal 13. Well, 9 times 4 gives me 36. And if I add those, 9 plus 4 gives me 13. So there are my two numbers. Now, since this is just an x squared and there's not a coefficient in front of that x squared other than 1, these are my two factors. So my two factors become x plus 9 and x plus 4. You can go through that whole grouping method and group them all together and do all of that, but you're going to come up with x plus 9 and x plus 4. If you'll remember, coefficient of 1, these are the two factors. So here are my two factors. They're set equal to 0, and I'm going to do it just like I did this. So I'm going to take x plus 9, set that equal to 0, and x plus 4, and set that equal to 0. Then I solve these equations just like I solved the other one. So I subtract 9 from both sides, so x equals negative 9. And then I subtract 4 on both sides, so x equals negative 4, which tells me that this quadratic, if I graph it, crosses the x-axis at negative 9, 0, and negative 4, 0. Yes, you need to go ahead and write them as an ordered pair, because remember, the solution to a quadratic is the point where it crosses the x-axis. It is a point on the graph. So you want to write it as an ordered pair to make sure that that's understood. This next one, this 9x squared minus 81 equals 0. We're going to have to go way back and remember that the first thing we should always do is look for a greatest common factor. We did not do that in this first one because there wasn't a greatest common factor. I should have gone ahead and pointed that out, but there wasn't one. But this one does have a greatest common factor. What's the greatest common factor for this little binomial? 9 is what they have in common. So the first thing we're going to do is factor out a 9, leaving us with x squared minus 9 equals 0. But I have not still done factoring, because this x squared minus 9 is a difference of two squares. There's the difference with the minus sign. Perfect square x squared, perfect square 9. So I need to factor this. The 9 that I factored out a minute ago stays. And then to factor this, the square root of x squared is x. The square root of 9 is 3, so I end up with x plus 3 and x minus 3. And this equals 0. Now I treat it just like I did the first two that I did. I got to set my factors equal to 0, except this time I have three factors. I have to set all three equal to 0. Well, 9 does not equal 0, so that automatically is not something that I have to worry about. But my other two here, my x plus 3 has to equal 0, and my x minus 3 has to equal 0, and then I solve. Well, this one right here becomes x equals negative 3, and this one becomes x equals positive 3. So this quadratic right here, if I were to graph it, crosses the x-axis at negative 3, 0, and then again at positive 3, 0. So this one's a pretty little symmetrical thing. Your y-axis is going to be your axis of symmetry for this one because you can see negative 3 and positive 3 the same distance from 0. So next example, the 6x squared plus 5 equals negative 17x. This one doesn't equal 0. You cannot solve a quadratic if it does not equal 0, because that is the whole point. You are trying to find what x equals when y is 0. So I've got to make this equal to 0. And I'm going to do that by adding 17x to both sides. So it cancels over here. And I'm going to make sure I put everything back in order. So I'm going to have 6x squared plus 17x plus 5 equals 0. Now it equals 0, but now I have to factor just like I had to factor before. So I start by doing a times c. 6 times 5 is 30. And I need two numbers that multiply to be 30 that add up to equal 17. Well, those two numbers are 15 and 2. Now, since this x squared has a number larger than 1 in front of it, I have to go through, rewrite, do the grouping method. So I'm going to rewrite this as 6x squared plus 15x plus 2x plus 5. And then I will factor. The greatest common factor for this set of parentheses is going to be a 3x, which leaves me with 2x plus 5. And my greatest common factor here is going to be a 1, leaving me still with the 2x plus 5. And I forget all this is equal to 0. Well, so my two factors are 3x plus 1 and 2x plus 5. So I have to take both of those factors and set them equal to 0. So I have 3x plus 1 equals 0, and I have 2x plus 5 equals 0. Solve these, so I subtract 1, I end up with 3x equals negative 1, and when I divide by 3, I have x equals negative 1/3. That's not going to be one you can convert to a decimal because 1/3 is repeating. You're just going to leave it as negative 1/3. And then when I solve this one, I end up with 2x equals negative 5. And then I divide by 2, so x equals negative 5 over 2. And since I left the first one as a decimal, I'm going to leave the second one as a decimal just because. And then I can write them as an ordered pair. So it crosses the x-axis at negative 1/3, 0, and negative 5 over 2, 0. Now the last example on here is different because I now have fractions. Do not be afraid because we can clear the fractions and have nothing but whole numbers left, and it will make things much, much easier. So we're going to clear the fractions. In order to clear the fractions, remember, we're going to end up multiplying this entire thing by something that will make these denominators go away. Well, since I have two different denominators, I need to pick something that both of them will go into. Well, 12 will go into 12 very easily, and 3 will also go into 12 very easily. So if I multiply this entire thing by 12, it will make this 12 cancel, leaving this with an x squared. Because it would become 12x squared over 12. The 12s would just cancel out. And then when I multiply over here, remember this is the same thing as 12 over 1. Well, 12 times 2 becomes 24x over 3. And then also, this is 4 over 1. I have to multiply this times this as well. Well, 12 times 4 is 48. It becomes 48 over 1, which is just 48. So the only thing I have to do is simplify this. Well, 24 divided by 3 is what? It's 8. So this becomes x squared minus 8x equals 48. So now I have no fractions. I don't have to worry about that. My fractions have been cleared, but now I still have to factor. But first, I got to make it equal 0. I'm going to do that by subtracting 48 on both sides. So you're going to end up with x squared minus 8x minus 48 equals 0. And then we're going to factor. Well, I need to multiply the a times c, 1 times 48, that becomes negative 48. I need two factors of negative 48 that add up to be negative 6. I'm sorry, they add up to be negative 8. It tells me one of my numbers is going to have to be negative. My two numbers then are going to be negative 12 and positive 4. So when I multiply those, they give me negative 48. When I add them together, they give me negative 8. Like the example before, because this has a coefficient of 1, these become my two factors. So my two factors are x minus 12 and x plus 4. Set them both equal to 0, and we're going to solve them. So for this one, x equals 12, because I added 12 to both sides, and for this one, x equals negative 4. So this quadratic, even with all the fractions and everything in it, if I were to graph it, would cross the x-axis at 12, 0, and at negative 4, 0. So those are my two solutions. So now let's work backwards. Now if I have the roots, I have to go backwards and find what the quadratic equation is. So this time I'm given the roots, and I'm asked to find the quadratic equation. So what I know is that x equals negative 2, and I also know that x equals 5. So I'm going to have to work backwards. And the way that I work backwards is, if you will remember, what I need is for this to equal 0. Because what I need is to get back to right here, to something that looks like this, with the x on the the x on the left hand side, and it needs to equal 0. So I need to end up with a statement that looks like this, or a statement that looks like this, where x with everything else is equal to 0. It is not equal to anything else. Right now my x is equal to negative 2. I need it to be equal to 0. Well, to make this equal 0, if I add 2 to both sides, the left hand side becomes x plus 2, and when I add this, it equals 0. So now I'm good, okay? One of my factors is x plus 2. I'm halfway there. I'm going to do the same thing here. I've got to make this equal 0. And to do that, I'm going to end up having to subtract 5 from both sides. So the left-hand side becomes x minus 5 equals 0. So here's what I have. I have x plus 2 and x minus 5. Since these are both equal to 0, that tells me that my two factors for my quadratic were x plus 2 and x minus 5. If I want to get back to the quadratic equation, I now have to multiply these two things together using the double distributive property. So again, we're going to have to remember some stuff we learned a while back. So we're going to do x times x gives me x squared. X times negative 5 is negative 5x. 2 times x is 2x. And 2 times negative 5 is negative 10. Put your middle terms together here so that you end up with x squared minus 3x minus 10 equals 0. This is the quadratic that has these two numbers as solutions. So let's do one more example. We'll do another one. I have right here x equals negative 3, and I have x equals 5 over 2. This one's pretty simple. You end up adding 3 to both sides so that you have x plus 3 is 0. This one is a little bit different because you have this fraction. In order to clear the fraction, remember that we start by multiplying everything by the denominator. So we're going to multiply everything by 2. That cancels out this 2, so I end up with 2x equals 5. And then I have to subtract 5 from both sides so that I can get this equal to 0. So then I have 2x minus 5 equals 0. So my two factors are x plus 3 and 2x minus 5. And I multiply those together to get my quadratic. So x times 2x becomes 2x squared. X times negative 5 is negative 5x. 3 times 2x is 6x. And 3 times negative 5 is negative 15. Then you put your middle terms together, so you have 2x squared plus x minus 15 equals 0. This is the quadratic you started off with, and so that's just how we work backwards. That is solving equations by factoring. I will see you guys tomorrow to practice some more of this.